Hi, I am Jatin from C International School, and in this video I am going to demonstrate the electrolysis of dilute and concentrated sodium chloride. First, let's know what's electrolysis. Electrolysis is the decomposition of a compound in the aqueous or fused state when direct electric current is passed through it and the ions migrate to the electrodes and discharge as neutral atoms. Now that we know the definition of electrolysis, let us also know a few basic concepts of electrolysis to understand the experiment later. The first rule is that the ions which are present at the bottom of the reactivity series discharge easier at the electrodes. This is because the ions which are present at the bottom of the reactivity series gain or lose electrons easier and faster than the ones present at the top of the reactivity series. The second rule is that if the concentration of an ion is higher, it has higher chances of getting discharged, even if it is at the top of the reactivity series. First, I will show you the electrolysis of dilute sodium chloride solution. As you can see, the electrode in the right is the cathode and the electrode in the left is the anode. How do we know which is the cathode and which is the anode? The electrode which is connected to the negative terminal is the cathode and the electrode which is connected to the positive terminal is the anode. Here the electrolyte is dilute sodium chloride solution. We get 4 ions here, Na+, Cl-, H+, and OH-. The cations are H+ and Na+, and the anions are OH- and Cl-. The anions migrate to the anode and the cations migrate to the cathode. Now let's see which ions get discharged as neutral atoms at their respective electrodes. For the dilute NaCl solution as the electrolyte, the H+ ions are discharged at the cathode and the OH- ions are discharged at the anode. The 4 OH molecules combine to form water and oxygen. The water falls back into the electrolyte and the oxygen is liberated at the anode. You cannot see much oxygen bubbles at the anode. This is because iron is an active electrode and some of the oxygen liberated is reacting with the iron. That is why we see less oxygen bubbles. If we use an inert electrode like graphite or platinum, we will be able to see more amount of oxygen bubbles. Now let's see the electrolysis of concentrated NaCl solution. What is the difference? The only difference here is that I have added more salt in the electrolyte. So the number of sodium and chlorine ions increase. So let's see what happens. Here again we see hydrogen bubbles at the cathode. What's the reason? The reason is simple. Hydrogen bubbles, even though their concentration is less than Na+ ions, they easily gain electrons than Na+ ions. That's the reason they are discharged at the anode and not the Na+ ions. Now, see the anode. What do you see at the anode? There's not much difference. But wait for it, you will know what's the difference. Here again, we see hydrogen bubbles at the cathode. What's the reason? The reason is simple. Hydrogen bubbles, even though their concentration is less than Na+ ions, they easily gain electrons than Na+ ions. That's the reason they are discharged at the anode and not the Na+ ions. Now, see the anode. What do you see at the anode? There's not much difference. But wait for it, you will know what's the difference. After some time, we see that some greenish yellow gas has started accumulating around the anode. What's this greenish yellow gas? you may ask. Well, chlorine is the greenish yellow gas. Chlorine is discharged at the anode because its concentration is higher than the concentration of OH ions. I hope you all understood this video. It will be better if you try this experiment on your own. You will learn faster and easier. Thank you and have a nice day.